aviation world is plotting to soar into the future. NASA has a 10-year plan which they hope will help accelerate aviation research. In that plan, they intend to design, build, and test a series of piloted X-planes, experimental aircraft, which will test advanced technologies like biofuels and battery-powered aircrafts. We all remember the Concorde, a passenger jet that flew from New York to London in just 3.5 hours. The plane stopped flying in 2003 due to low passenger numbers and maintenance costs. Well, Boeing thinks it can do better, an aircraft that could get you almost anywhere in the world in less than 3 hours. Their idea? Commercializing hypersonic travel. A working parent could fly overseas for a business meeting and be back by dinner. Joining us to discuss, Kevin Bocut, Senior Technical Fellow and Chief Scientist of Hypersonics for Boeing. So, Kevin, this didn't work with the Concorde. Why do you think it'll work now?
Well, it's many decades later, and we've been working on hypersonic technology for about 6 decades now. Started out with the X-15 that led to the space shuttle, which was successful. And in the past about decade, we've been flying hypersonic engines like scramjet engines and developing technology, materials technology, and doing a lot of work in design. We have a lot of very powerful computers today. We can simulate airflow and propulsion flows, the structure, and we bring all that together, the propulsion technology, the materials technology, the simulation and design capability, and we think that in maybe 20 years or so, we'll be able to design a hypersonic airliner.
So just how fast are we talking here? Mach 5?
Mach 5, yeah, so 5 times the speed of sound. To put it in terms you might be able to understand or kind of feel, that's a mile per second, 3,600 miles per hour. So it's very fast.
So what would this technology mean for me or for an average passenger?
Well, it's really saving time, right? So what's the value of speed? Today we fly fast, subsonic speeds, Mach 0.8 approximately. If you go supersonic, you'll be twice that. Hypersonic at Mach 5, that's 6.25 times faster than how we fly today. So think of getting from New York to London in slightly more than 2 hours, or from LA to Tokyo in about 3 hours. It's so fast that you can get there in a day and come back. You could wake up, go there for a business meeting, come back and sleep in your own bed, and that's revolutionary.
What are the safety concerns here for the aircraft moving at such speeds and for our physical condition within them?
Okay, I'm going to start with the latter, physical condition. You won't feel anything really different than you feel today. Your body doesn't sense speed. You fly at 500 miles per hour, you don't feel that. What you feel is acceleration. What'll be different about this airplane is that feeling that you get on takeoff. You're pushed back into your seat, lasts about a half a minute or a minute. That's going to last about 10 minutes. It'll be gentle, about a third of the force of gravity, and you'll accelerate up to 95,000 feet in Mach 5. So it really won't feel extraordinary. Safety-wise, the one thing that's quite different is the faster you go, the hotter the temperature of the airframe structure. It's due to frictional heating of air that heats the surface. So flying at Mach 5, that temperature is about 1,100 degrees Fahrenheit. That means you can't use aluminum. You've got to use higher temperature materials like titanium, and we have advanced titaniums that can withstand that temperature. But now the air, as it slows down to the airplane, the air's hot as well. So thinking of managing that temperature, we're going to have a cooling system that cools the air before it goes into the cabin. And we thought through the things like decompression and how we would deal with that. And it's basically tied around cooling the air before you supply to the cabin, and we think we can manage that safely. And of course, Boeing builds safe airplanes, so this airplane is going to be safe as any Boeing airplane.
The Concorde had a problem with cost in making this economical. What would be different now?
Well, part of it's technology. We've got more efficient engines, we've got lighter materials, so the overall airplane will be more efficient. And the other part of it is economics. What is the value of speed? And frankly, we don't know at this point. We're not exactly sure. It's a revolutionary change in speed, so it's going to come down to what is the value of such a large increase in speed. And that's something we're studying. We really don't know. So before this happens, there's got to be a convergence of the design, the regulatory aspects, and the market. And when those converge, we'll be ready to do something like this.
When will commercial travel on a hypersonic jet be available?
Well, we don't exactly know what that time is. It depends on that convergence of things that I talked about, but we anticipate it'll take at least 20 years. It'll take some time for all those things to come together. So it's not going to, when any airplane takes, a commercial airplane takes a fair amount of time to develop. So this is going to add a little more time, higher technology, et cetera.